Okay, 4.3, we're going to continue on with some more trig. So you're going to learn about trig functions of any angle, trig functions of some real numbers, both giving exact values and decimal approximations. And the unit circle is technically in this section. I know we've already done it, but technically the unit circle you can find in the book in this section. A couple vocab terms first. You need to know what initial side and terminal side of an angle are. You also need to know what positive rotation is and a negative rotation. So we're going to go counterclockwise for our positive in math. So we start off with 0 degrees facing, to the right here. And then we're going to rotate positive counterclockwise. If we go the other way, it'll be negative. So clockwise is going to be negative for us. Okay, so coterminal angles. We've done problems with coterminal angles already in the homework, so we've gone over what those are. But they're just angles that are in the same direction. So for example, 30 degrees here. And then if I add 360 to that and give you 390, 30 and 390 are coterminal angles because they point in the exact same direction. So here's an example then of finding a positive angle and negative angle that are coterminal with 45. If you draw 45, I want one to be positive, one to be negative. So I'm going to add 360 to 45 to get the positive one. This gives me 405. So 405 degrees is the same direction, but obviously it's a different angle, technically. And then the negative one, I'll take 45 and I'll subtract 360. Negative 315. So there's two coterminal angles. One's negative, one's positive. We can do this with radians as well. So let's say we have one like this with pi over 6. Pi over 6, I like to use fractions for that like we did in the unit circle. So divide pi up into 6 parts. 1, 2, 3, 4, 5, 6. And so there's pi over 6 right there. We can add 2 pi to that to get a positive one, in which case we want common denominator, so we're going to multiply the top and bottom by 6. And that gives me 13 pi over 6, and that would be then the positive coterminal angle. To find the negative one, I just subtract 2 pi. So I just subtract 12 pi over 6. It gives me negative 11 pi over 6, which is the same exact direction, but to get to that one, instead of rotating positive, we rotate negative around to this point right here. But it's the same direction. We're also going to do problems in the homework like this, where I give you a point on the terminal side of an angle. So let's put that point on there. So it says the angle is in standard position and the terminal side contains the point 3,5. That tells us we're in the first quadrant. So make a triangle in the first quadrant where this side's 3 and this side's 5, because we're going over x and up 5, up y. Then from there we can find the 6 trig functions. So we want sine, cosine, tangent, and then we want the reciprocal of sine, which is cosecant of that angle. We want the reciprocal of cosine, which is secant, and we want the reciprocal of tangent, which is cotangent. Okay, so to find sine, we're going to do opposite over hypotenuse, so we need the Pythagorean theorem to find the hypotenuse, which is square root of 34. So sine would be 5 over the square root of 34, and then just flip that for this answer. And then cosine is adjacent over hypotenuse, which is 3 over the square root of 34, and flip that for secant. And then tangent is opposite over adjacent, 5 over 3, flip that for cotangent, 3 over 5. Okay, the next thing you want to know is these trig functions of any angle. You might see this in the book, things like this. All this is the Pythagorean theorems. These things should actually be pretty straightforward. If you draw an angle, and you call this x and you call this y and call this the radius of that circle, then obviously sine of this angle, theta, is equal to opposite over hypotenuse. So sine is y over r. Whatever this value is divided by whatever this length is. So these are things you kind of already know. And the Pythagorean theorem, for example, is a squared plus b squared equals c squared for this triangle. So if you square root it, you get the radius is going to be equal to this quantity right here. So it's things you know the relationships for sine, cosine, tangent, and the reciprocal functions, and you also know the Pythagorean theorem. So this might look confusing in the book, for example, but these are all things you actually know already. So to apply them then, we're going to do problems like this, where you can find the exact value of 210. 210, if you graph this, is around 180 plus another 30. So here's 30, here's 180. So there's 210 degrees. And we can then make a triangle right here. It's a special right triangle. It's a 30, 60, 90 triangle. We know these values on our unit circle. The sign is going to be the y value, which is negative 1/2. So we want that answer. And if you don't remember that from the unit circle, or you don't have your unit circle, you can also use the special right triangle values. If you write these relationships down and do opposite over hypotenuse, you have x over 2x, which is 1/2. And make sure that it's negative because you're going down. Okay, I'll just do one more example then. In the homework, I'll give you basically some clues sometimes about where you're at, and then ask you to find other trig functions. For example, this wants us to find sine and cotangent using these clues. So we're told that the cosine of theta is equal to negative 8 over 17. Cosine is the x value, so that means we have a negative x value. It tells us we're in the second or third quadrant, or somewhere over here. And then we're told that the cosecant is negative. The cosecant is really 1 over sine. So when they tell us the cosecant is negative, what they're telling us is the sine is negative. If the sine is negative, that's the y values. That tells us we're in the third quadrant. So based on this clue, we knew we were back here somewhere. And then based on this clue, we knew that we had to be in the third quadrant. So what we do is draw a reference triangle in the third quadrant now, and then label the relationship that they gave us. For cosine is adjacent over hypotenuse, this would be negative 8 over 17. You can do the Pythagorean theorem here, not with the negative 8, but with the positive 8, and you can get this length, which is the square root of 353. And I'll make that negative just so we know that we're going down to that point. Okay, so now we can find the sine, which is opposite of our hypotenuse. So the sine for part A is going to be equal to opposite negative square root 353 over 17. And then the cotangent is going to be the reciprocal of tangent. So instead of doing negative square root of 353 over negative 8, we'll do 8 over square root of 353. The double negatives cancel. There's part A. Part B now gives us a different triangle. It tells us that the tangent is negative 1/2. So tangent is sine over cosine. So it's telling us that sine over cosine is negative. And then it tells us that cosine is positive. If cosine is positive, we know we're somewhere over here because the x value is positive. Now, if they tell us that tangent is negative, if cosine is positive, sine must be negative. So if cosine is positive and sine is negative, we're talking about the fourth quadrant right here. So we know we're down here somewhere based on the clues that they gave us. So we'll draw a reference triangle, and we'll label the relationship for tangent, which is opposite over adjacent, where this is negative. If we do this Pythagorean theorem, we get square root of 5. And then we can find the sine and cotangent for part B. The sine is equal to opposite over hypotenuse, which is negative 1 over square root of 5. And we also need the cotangent, which is equal to the reciprocal of opposite over adjacent, so it would be adjacent over opposite, which is 2 over negative 1, so that would be negative 2. So that's how we find exact values of different trig functions given some clues. There will be a ton of problems like that in this next homework assignment. Hope this helps.